Good evening, Walter and Donna. And Philip. Right this time. How's it going this week?
Hi, Jerry. It was good to see you the other day.
Hi, Shante. Same here. Can you hear me?
Yes.
Oh, okay, nice. Because I'm still in my office. It's my first time to put myself in the office, not my apartment.
Okay.
Well, yeah, it was my pleasure to see some of you during the weekend. This week, we learned about hypothesis testing. How did you find about it? Any comments?
I'm actually still working through the videos. Last week I was focused a lot on studying, so any insight you could give would be great.
All right, so let's see what we can what I can do to help you through assignment 9 this time. There are only 2 questions though, so I'm not sure whether it actually takes longer or shorter this time to finish them. But did any of you complete both questions?
I definitely tried, but I'll be honest. So the second question is, I think it's a little bit difficult, not in the doing of it, but it's an interpretation question, right? Like the actual skills to do it are not hard, but I'm kind of running up against a wall in B and C.
So did other students have similar questions regarding how to interpret in problem 2, or do you have any? Do you have different situations?
I'm curious, is all the information that we need, like on the summary, on the regression, the output? I mean,
yes,
it is. Okay.
Yeah.
So I get where he's talking about when it comes to an interpretation thing. When it comes to B and C, I got a little hung up on that as well.
I mean, for interpretation, the information is directly in the model,
regression model.
But
right?
I think there's also a question regarding the 5% level of significance. For that, we also need to use the critical values. The values will be found in the statistics Excel file, because remember we did the confidence interval and also critical values in that worksheet. So we need to refer to critical values from there. All right, so it appears question 2 is a more popular area for our discussion this time. Does anyone would like me to address? Would want me to address problem 1?
Yes. Yes, please.
Oh, I see. All right. So why don't we just start from each part and let's see how you did them. So in problem 1, in part A, we need to test whether the sample provides sufficient evidence against, right? There's a claim at 5% level of significance, and we also need to calculate the p-value and make a conclusion using that. So I would like a volunteer to share his or her answers, and I'll start from there.
For that one, I got a p-value of 0.4%.
Okay.
Is that wrong? Somebody else said, sounded like, not you, Jerry. Somebody else was like, So
That's what I got.
No, I got a p-value of 0.0042.
Yeah.
yeah, that's what I get. Yep.
Don't get nervous. It's the same answer. You just translated to percentage, so no worries. Yeah. Well, usually you see p-value not in percentage though. So yeah, I haven't seen p-value expressed in percentage.
Well, that's funny
But
though.
it's fine. Yeah.
Well, Thomas
not
in
a
class
problem.
was calling them percentage, which I thought was strange as well. But he was saying he was calling them percentages. So we shouldn't. We should just forget about percent and just call it regular. It's raw value.
Yeah, I just because I've never seen p-value expressed in percentage. But to be honest, in professional reports, you probably wouldn't want to, have p-value included in the body text. If any included in the appendix, because not everyone is a big fan of seeing all the statistics that they may or may not understand. Yeah, so yeah, you got it. Good p-value. So how did anyone need help in problem A? I mean part A. So I would also like to know in the statistics file, in the tab of hypothesis testing, there's usually 3 columns for left-tailed, two-tailed, and right-tailed, right? Which of these 3 options did you choose for part A?
You
Right
would choose
tail?
the right tail.
Well, excellent. So it seems there's no ambiguity for any of you. Then, yeah, I'm glad, because it might be a challenge for some people to tell the difference and choose the correct one. But do you need any further explanation on why we chose right tail here? It appears that all of you understood it very well. So excellent. And how did you address part B?
Hold on a second.
Lisa?
I thought it was a left for part A, number 1, part A, right?
Mm-hmm. Okay, I see.
I got the left. I don't know. I wrote it down as a left tail because you're
Okay.
looking at. That's how I understood it. I haven't. So can you go over that? Why is it a right tail?
Okay, sure. For that, I think let's review the question together again. So here, basically, we are discussing about the delivery time of the Amazon, right? So they had a 60 minutes target that the company plans to develop the delivery zone to an average of 30 minutes or less, right? So this is the average or the reference value that we need to use. Then we take a random sample of 50 deliveries, right? So this is our sample of 50 deliveries. Then we get an average, this is the sample mean, right? 32.1 minutes. And we also have a standard deviation. Can anyone tell me whether this 5.4 minutes is a sample standard deviation or population standard deviation?
Sample.
Sample.
Excellent. Okay. Yeah, this makes a difference in terms of which distribution we should refer to. So which distribution did you use when doing the hypothesis testing?
The T distribution.
Well, excellent. yeah, here, because we do not know the population standard deviation, but we know the sample standard deviation, then we try to infer from the sample standard deviation about the population standard deviation. That's why we use T distribution when doing hypothesis testing. But yeah, don't get me wrong in this. I noticed that some of you in, the other cluster in exam expressed that they would want to use normal distribution because the sample size exceeds 30. I can see some of the reason is why they made such a claim. The students wanted to use normal distribution because they see that the central limit theory may apply here because of the large enough sample size. However, the central limit theorem applies to describe the distribution of the population means. So it's a different question than doing the hypothesis testing or building confidence intervals. So what the central theory limit describes is that no matter whatever the original distribution of the random variables is, its mean value is still normally distributed. However, when we collect samples and derive the sample standard deviation from it, then we still need to use the T distribution. Although at the same time, the mean of the population mean underlying the samples are still normally distributed. So what we did here is we used a T distribution to infer a mean value that's normally distributed. So that's the distinction. I hope it clears about whether and where we apply the normal and the T distribution. All right, so why we need to use right tails here is that we need to first define our question. So here the question is to test whether the sample provides sufficient evidence. What's important is here against the claim that, let's see the claim, right? Yeah, an average of 30 minutes or less. So the claim is describing it as the average duration of delivery is equal to or smaller than 30 minutes. That means our null hypothesis is this, that the average delivery time is smaller. Here, the mu is smaller or equal to 30. At the same time, that makes our alternative hypothesis, HA, the complement of it. That means the alternative hypothesis is mu larger than 30. So that's why we depend the tail on the alternative hypothesis.
Okay, so just to, okay, I'm trying to understand it here. It says that the evidence against Bezos' claim. So Bezos' claim that it's going to take less than 30.
Yeah. So
Okay.
this is H0 or null hypothesis.
So the null hypothesis is his claim, not. Oh, so I got that backwards. I had the null hypothesis over 30. That's why I went left-tailed.
Yeah, I can see that. So another thing that might be helpful to consider is that here, basically, the original or the reference population here is that smaller or less than 30, right? It's a shorter duration, but our sample gives a higher average, that's 32.1 minutes, right? Our question is basically whether this increase of the 2.1 minutes is significant or not, right? So when we compare this, whether the a sample has a population mean that's greater than the reference population, then we use right tail. So basically, this larger average, will that be significant or not? So that, that's why we use right tail. However, if our comparison is to see whether the sample mean, the population mean behind the sample is shorter than 30 minutes, we got a sample average delivery time of say 25 minutes. Then in that situation, we could use a left-tailed test to see whether the population mean behind our collected sample is actually much shorter than 30 minutes. Yeah. So I think a good useful way is that first we describe our null hypothesis in this way. So we have the an equal sign here. Then we use an equal sign for the alternative hypothesis to tell whether if we should use right tail or left tail, or in the case if it's an equal sign here for the alternative hypothesis, we should use the two-sided test. All right. Let that most of you got our problem 1 down really well. So let's hop on to problem 2. It seems we could benefit from some discussion here. Okay.
So Jerry, for B, you would still reject your null hypothesis, correct? Because it's less than the p-value.
Yeah, I'll get there very soon.
Okay.
Let's have a review of the whole problem so that everyone is on the same page. Okay, first we have a summary output of a linear model, right? And it's, I think, the same result as what we practiced earlier on the effect of advertising expense on the revenue. So here we have a simple linear regression model. There's only one variable in the model. And we are assessing the relationship between how much money was spent on advertising and what's the outcome variable. It doesn't directly say here. Okay, during the particular amount of 15 stores of a retail chain. Well, I believe it's about the revenue. So is there a statistical significance relationship between money spent on advertising and sales? Yeah, well, the outcome is sales, apparently. And I believe most of you did the part A already, test at 5% level of significance and explain your approach. So let's finish this part before we analyze what we do about part B. So can I have a volunteer to describe what you did in part A?
I thought the null hypothesis was that B is equal to 0, and the alternative was B is not equal to 0.
Excellent. Do you have more when addressing part A?
I also did, the t-test I looked at the table and it was a 6.07467 and a p-value of 1.4603, which is almost 0.000, which is like a 0.
Yeah, as I highlighted in the shared screen. Yeah, wonderful. Did you have more when answering this question?
Yeah, I concluded that the relationship is not statistically significant
Oh, so,
because
okay.
the p-value of 0 was less than the alpha of 0.05.
So your conclusion is?
I rejected the null hypothesis.
Okay, and that means?
That the relationship is statistically significant.
Oh, okay, excellent. Sorry, earlier I thought you said not significance. I was confused. Okay, all right. So excellent work. So Tilda made effort in all the necessary steps for us to complete a hypothesis testing. I know that most of you should have the correct approach, or and you derived the correct answer. However, you may not have the complete procedure for a full hypothesis testing. So let's see the components of a hypothesis testing. As Tilda described, first we need to identify the null hypothesis and the alternative hypothesis. So as she described, the null hypothesis for most regression output is always the coefficient equals to 0. So that makes our alternative hypothesis, HA, about the coefficient not equal to 0. So the summary output always reveals such information. And how can we test it? As Tilda described, we refer to the table where you see the t-stat and p-value. And if the p-value is smaller than the level of significance we want, which is here 5%, that makes it 0.05, right? So if the p-value is smaller than this, we claim that this coefficient is significant. That means we reject the null hypothesis, and there's a significant statistical difference of this coefficient. That's the advertising effect from 0. So there's a significant effect. So we should have 4 parts. That's the description of the hypothesis. So we need to list H0 and HA, and we also need to refer to the statistics. Here we have the t-stat and the p-value available already, right? And next, the third part, we need to make a decision. So here we reject the null hypothesis because p-value is smaller than 5%, right? And the last part, we need to interpret or make a conclusion. That means the advertising expense has a statistical significance on the sales. So make sure we have all 4 parts, and that also helps us to understand what the test was about. So it's very clear that how the test was formed. All right, excellent. Any question about part A in problem 2?
Isn't the F statistic, isn't that a test that the the F statistic in the top part of the, doesn't that automatically test that the correlation is 0? So the significance of the F is essentially a null hypothesis that correlation equals 0.
Oh,
because if you look at it, it's this, in this particular case, it's the same number, right? Like it's the same 1.4 times 10 to the minus 5th. So is it fair to say that because this F significance is basically 0, that it implies there is a statistically significant relationship?
Yes, for this question, you can actually use it. So what he was asking about is that here, he noticed that here the significance F, this value, is the same as this one, the p-value of the t-test. For a simple linear regression, when we have only one predictor in the model, it's always this case, because the F-test is just a, well, it's related to a t-test. And in the one variable case, if we have only one variable in the model, the p-value of both tests always equal to each other. So it's also true that in this case, if we take a square of t statistics, it'll be same as f. So we can make it simple. So let's see the square of this. Notice that it's 44. Whether it can be seen clearly in your screen, it's somewhat smaller. So the square of the t-stat statistic is almost 44.9, right? As we go back to this one, it's the same value as here. So these test statistics are related, and he was right that in this particular case, because we have only one variable in the model, we can also refer to the f-test to say that because there's a significant variation that can be explained by advertising. That's why we say that there's a significant relationship. So it's another alternative way you can test this hypothesis. We refer to f-test instead of the t-test. Wonderful. However, I would like to make a point that in the case that if we have more than one variables as predictors in a model, so remember in the other homework we did, there's another variable like the the expense on newspaper and TV, right? So we have two different variables of advertising effect. In that case, the conclusion on t-test is the individual coefficient. However, the f-test will tell us about whether both variables, whether any of the both variables would be significant. So they answer different questions in that case.
Can you repeat that?
Oh,
please?
yeah. Yeah. So let's see. I was saying that in the case if we have more than one predictors in the model, so we have multiple linear regression model. In that case, the t-test will be answering a different question than the f-test here.
So in that case, in other words, Jerry, if we have multiple regression, we have to use the p-values and we can't go by the f-test because the f-test just tests the entire model, not the individual elements.
You're close, but there's some confusion. I see. So first, here, the significance f is also a p-value. It's the p-value regarding the f-test. It's just in Excel file. Somehow they decided to name this value significance f, but that's the p-value of the f-test. These are the p-value associated with the t-test. They answer different questions. A t-test is about whether a single coefficient, like here, the beta 1, is equal to 0 or not, right? The f-test, on the other hand, answers the question regarding whether all the coefficients equal to 0. If we have multiple coefficients, say, advertising on TV, advertising through newspaper, so we have multiple variables here, right? Then corresponding to each of the variable, we have a coefficient. Then we can test whether all these coefficients equal to 0. So each of them equal to 0. We can test them together. Then that's what the question and f-test answers. So it's like a simultaneous test. Did I make myself clearer or?
Could you give an
Did I-
example? I think you probably
Okay,
somewhere
let's
you
see.
have
Let me find the
regression,
homework we
multiple
did
regression.
earlier, so that we can find one. So did we discuss what an F-test is about in the class, in any of the videos?
I think the F-test wasn't even in the videos. I didn't even do an F-test. Was it in the videos?
No, it wasn't. He talked about it in class, and I'm just confusing the issue here. I apologize.
Yeah. I think all you had, yeah, isn't all you had to do for A was look at the p-value close to 0 and then do your hypothesis testing where you just compare your t-value versus the t at the 97.5% plus or minus interval.
Oh, sorry, could you repeat your question? I was looking for the example, so I just found it.
Oh, I was just saying you just need to find the t distribution corresponding t at which is 2.16 and compare that with your t-value or
Oh,
6.67, right?
Are you already talking about part B, right?
A.
Oh, okay. Oh, I see. Yes, in A, we can also use the critical value and compare.
Right, because
yeah, in the example, we have the t statistic. The t statistic is 6.7, right? And the critical value in this case should be about less than 2, I believe. So because the t statistic is much higher than the critical value, so we reject the hypothesis, null hypothesis, and say there's significant difference. All right, here, so let me share my screen again. In homework 4, remember we did a few multiple regression models. Let me see which one. Okay, yeah, this is the example, right? So here, it's a related example. We want to assess the relationship between the sales and the different advertising expenditures. So we have television advertising and also newspaper advertising. So in this case, we have 2 predictors plus an intercept. So if we go to the F-test here, we notice that the significance F, the p-value of the F-test, test alternatively, is very small, right? So we would reject the null hypothesis based on the F-test that both of these coefficients equal to 0. However, if we use t-test, that means holding the other variable that's not under the test constant, we only focus on one of them. So here, the t-test answers the question regarding whether this particular coefficient of television, for example, is significantly different from 0. And we got a p-value for this that's, somewhat larger, right, than this F-test. And for the newspaper, we also got a t-test with a p-value of 0.02. Notice that these 3 values would differ because they answer different questions. So depending on what question you want to answer. For example, if in your case, you represent the television advertising department and your competitor in the same company would be the newspaper advertising department. And you want to say that our department makes a significant contribution to the company's sales, then you should use this t-test because that answers the question that controls for whatever is spent on newspaper or television advertising programs still makes a significant contribution to the company sales. However, if there is another department coming up, for example, social advertising, it's new, so there's no records of the relationship of social advertising, social media advertising before, then that department want to destroy both of these traditional advertising departments. So they will want to see whether any of these departments made any contribution to the company sales. So they would easily refer to an F test instead, because that simultaneously tests whether both of the departments make any contribution to the company sales. Did I make it clear, easier to understand using this example? We would hope so. All right, let's get back to our homework questions in homework 9. All right, let's see in part B. We have a different question here. Someone claims that every additional $1,000 spent in advertising will increase the sales by more than 2,000 in the population. Notice the keyword more than, so it decides our the tail that we need to use. So can we find support for this claim given the result of our analysis? Then we need to test and explain. And this particular case, it's requested that yes, we need to include all elements of the hypothesis testing, and we need to compare from part A. So I noticed that some of you had concerns in this part, and what was about it that's not so clear at this moment?
This, we set our null hypothesis less than or equal to 2, right? Because the slope you're saying is 2, and then your alternative hypothesis is beta bigger than 2. And then you do a right tail test.
Excellent. Yeah, that's the approach I would choose. But did some of you choose a different hypothesis to test? Oh, okay. So did all of you have a alternative hypothesis that's stating that the beta 1 here, the advertising coefficient, that's 3.77. In the null hypothesis, it'll be this coefficient less or equal to 2. And the alternative hypothesis would be this coefficient greater than 2. I say that using our practice in problem 1, we should be able to tell how we can structure this null and alternative hypothesis. So how did you complete the next step in the question?
Yeah, so I basically just calculated the critical value versus the t statistic, and I found that the t was greater than the critical value, so we reject the null hypothesis, and we claim that for every $1,000 in advertising, it will increase sales by more than 2,000.
Excellent.
And it's different from A because from A, we were saying that the slope was either 0 or not 0, whereas here we're saying its slope is bigger than 2 or less than or equal to 2.
Wonderful. Did other students have the same or different answers, or did you use different methods?
I
How
think
do
it
they-
was a different method.
Okay, how did you address this question?
I used the t-test and found that it was equal to 3.16. No, it was equal to, yeah, to 3.16 and a p-value of 0.038, which was less than the alpha of 0.05. And yes, there was I rejected the null hypothesis, but the explanation I had for A, which I just thought that A was just testing for the significance of whether there is a relationship between the money spent and advertising. But in B, I thought it was really testing whether the claim was that additional $1,000 spent on advertising will increase the sales by more than 2,000.
All right. Yeah, sounds excellent. So here,
And both of them are
sorry, did you have a question?
no, I'm just saying that.
Yeah, your
Would they be
method sounds
different answers?
legit and very sound. So, oh, right. Then can I ask Rishi again? So when you complete this question, did you calculate a t-value?
Yes, 3.152.
Oh, okay. I see. It's somewhat different than Tilda's, but I think it might be just because of rounding.
Yeah,
Because it's very
probably.
close.
Right.
Okay. Did other students have the same or different answers? Okay. All right. So for part B, unfortunately, we won't be able to refer directly to the regression output table. So we need to make our own test. Then it's a decision to make. What distribution we need to use and some parameters we need to plug into those tests. So apparently this is a hypothesis testing. And can I have one volunteer to answer which of the hypothesis testing table did you used for part B? Anyone? There were multiple choices we could use in a hypothesis testing tab. Which did you choose for part B in problem 2?
What do you mean by table?
Oh, so in part B, we need to use the statistics Excel file. There's a tab called hypothesis testing, right? And there are multiple different tables we can use to complete hypothesis testing. Which did you choose here?
Oh,
It would be that I think I would use the t distribution.
Okay, wonderful. Correct choice. Did everyone agree? Yeah. So t distribution is the always go-to distribution when we make coefficient test. And in this case, we also need to make a decision of what degree of freedom we need to use. Can one of you give me your answer?
So is 13 the degree of freedom?
Yeah, how did you get this?
I'm sorry, was there another question?
Oh, yeah, Ramani,
Yeah.
would you like to
Yeah,
elaborate how
no.
you got this decision?
Oh, I just got it from the residual, ANOVA under residual, and that's the degree of freedom.
Yes, excellent. So here, the degree of freedom must be n minus 2. The n represents the sample size because we have two coefficients estimated in the model. We have intercept and the coefficient without advertising. That makes our degree of freedom for the residue 13 because it's 15 minus 2.
It's 15 minus 2?
Yeah. So for testing individual coefficients, we always use the residue degree of freedom. In the future, if you run linear regression models, when you have multiple coefficients and multiple variables in the model, then for each of them to complete t-test to say, whether this coefficient is different from 0 or it's, greater or less than some reference level, we need to use a t-distribution with a degree of freedom equal to the residual degree of freedom. That would be equal to the sample size minus the total number of parameters or coefficients in the model.
Could you repeat that? Because I don't understand why you're using the residual, the 15 minus 2 as opposed to 15 minus 1. Could you explain that again, please?
Yeah, I shared. Sure. So here, that's the summary of table, output table, right? So here we have observations equal to 15. We have a regression degree of freedom equal to 1, residue equal to 13, and total equal to 14. All of these three different are different degree of freedoms. When we use a t-test here, see that these are t-statistics, right? It comes with a degree of freedom. The degree of freedom for these t-statistics are this one. So make sure we choose the correct one when we make t-test.
So you're saying anytime you use a t-test and you're going to, and you have to calculate the,
So here the t-test is about
you have to calculate the p-value. You must use you use the residual as the degree of freedom.
Here, this is the degree of freedom of the residue. Residue and the degree of freedom are two different things, but there's also a degree of freedom for the residue. Yeah, so then if it's too complicated, don't get frustrated here. Just remember that for completing our homework, we should refer to this 13 as the degree of freedom for the t-tests for individual coefficient. All right. So I hope that addressed questions about part B. Any concerns and doubts about part B?
Question, you said use the statistics file in the hypothesis test tab, and the answer was use the T. Does that mean it is the hypothesis test for mean sigma unknown? They're named differently.
I think what Jerry means is you're supposed to use a critical value sheet, not the hypothesis test sheet, right, Jerry?
Oh, wait. Yeah, there are two, but
yeah,
maybe both work.
Well, you can't use the hypothesis test sheet because you don't have the population mean or the significance level
I see.
or sample means.
Okay, yeah, good point. I didn't go directly to these sheets to
Yeah.
Okay,
take a
that's
look
what I
myself.
was. I was confused. Thank you.
I see.
The
Yeah, so-
critical values
Yeah.
sheet.
Okay, yeah, which is right. So, okay,
Sorry, something's just not clicking for me. I mean, I understand how to get the T values, the critical values from the T
okay,
score. I come up with a T score critical value of 1.77.
okay,
That's, you know, I've got
sounds
that.
good.
Something about this, my null hypothesis for this is that beta is less than 2000. Is that kind of where we, like, something about this just isn't clicking, and I just don't know what I should really be answering here.
Okay, so, take a look again for this question. So notice that this claim is that more than 2000, and we want to find support for this claim, right? That makes this claim the alternative hypothesis. So in the alternative hypothesis, we will say that, notice that the ratio is 1000 to 2000 here. So we need to test whether this coefficient, which currently is observed as 3.78, right, is greater than 2. So this would be the alternative hypothesis. So the null hypothesis, of course, would be the complement of it. So that be this coefficient beta 1 smaller or equal to 2. So that would be the question we are answering here.
So Jerry,
Did I? Okay, yeah. Did I answer the last question successfully? Or
Yeah, I think part of thinking in thousands makes a difference.
Oh, I see. Yeah, you do not try to put 2000 here. It would be
Right. Yeah.
very different.
so Jerry,
Hi, Karen.
the coefficient, the slope is 3.778 or $3,778. What does that tell you? I know, like, when we were doing the linear regression, that tells you basically for every $3,778, you're going to increase your cells. But when we're talking about the slope, with the null hypothesis being less than 2000, if our coefficient is erasing, it's 3,778. That's the slope of the regression line, right?
Yeah. Right.
So by doing this, I guess what I'm saying is, like, why would we be doing this when we know that? Is it just telling us, like, what's the likelihood of the slope being less than 2000? But even though we know it's greater than 2000.
Oh, I see. Yeah. So let me consider what's the best way to answer this. The value of making a statistical test here to compare the coefficient, the observed or the estimated coefficient value, and a reference value is that it helps us to answer a question regarding the, what do you call it, as the plausible range of the coefficient. So here, what Karen described earlier was there might be a minor error there. This coefficient describes to us that for, each $1,000 spent on advertising, we expect the sales or the revenue to be 3,700 more. So that's what this coefficient describes. And here we would like to see that whether in our collected sample, this effect of advertising is greater than this $2,000 increase in revenue based on 1,000 input. So we can, of course, test different reference values. For example, we can also claim every $1,000 in advertising would increase sales by $4,000 in sales. And we can also test this hypothesis. So here it's a simple practice to kind of assess the plausible range of this effect.
Okay, so just like testing different samples or different hypotheses.
Yeah, we can
even though
plug
we
in
know-
different values here. So maybe you would find a more useful test would be whether this effect is more than 3,000 or maybe 3,500 because it costs for each associated with the expenditure, you want to see this ratio, right? And usually you want it to be as great as possible. And associated with the advertising, there's also other costs that might be happening also to the proportion. So we want to make sure that this coefficient is large enough so that we are actually making lots of money. For example, I know that in movies, right, when we spend usually the cost of making the movie plus advertising needs to be at least like 4 times smaller than their box office so that the production team can make money. Otherwise, they don't because there's also revenue shares happening, right? So here we just can use this method to test different reference values.
Okay, I mean, I get that, but I guess when I look at this regression table, I'm like, okay, I know the p-value is significant already because it's like -2 to the 5th power. So why would I want to go less than 3,700? Like, why wouldn't I test more than 3,700 to see what I can push it to? Other than
I
just
was
have to
not
let it-
sure whether I understood your question because this t-test here already in the output table answers a different question than in the other in part B. Here in the test shown directly in the output table, this answers the question regarding whether this coefficient is different from 0, right? And here it compares whether this coefficient is greater than 2. There are some comments here.
I think
So
what,
Jerry,
Well, let's see. There seems 2 students.
oh, go ahead,
questions here.
Ramaji.
no, I just wanted to know, so to cut to the chase. So I put in the critical values in the t distribution, I put the cumulative probability at 0.975. The degree of freedom is 13, and so the corresponding t is 2.16. So am I thinking about this correctly, or? And then you make it, and I did it because I did the 0.975 because it's the right tail.
Mhm.
Okay.
Actually not. It seems you use the cumulative probability does
Maybe
it say
that's-
fx or 1 minus fx?
Okay.
Hey, Jerry, I think what Karen's asking is when you look at the regression model, right,
Okay.
you get a coefficient for advertising that's saying 3.78, meaning for every $1,000, we should see an increase in $3,780 in sales. And when we look at the p-value, it's basically 0, so we know that it's statistically significant.
Yeah.
So the question is asking, okay, for every $1,000, it's going to increase my sales by 2,000, but conceptually thinking, we already know that advertising $1,000 should increase by $3,780. So why even go through the hassle of testing this claim when we can already look at this a summary output and see that it's $3,780 anyways. Is that, I think that's what she was asking,
Oh, okay.
Yes, that's what I was asking.
right?
Well, good point of thinking. I guess when these questions were formed, it was not designed to be uh, that conceptually necessary. It might be more technical
Right.
to see how we can use a method to test different ranges of plausible ranges of a coefficient. So as I said, of course, there might be more useful reference values we could use to make the test more interesting. So we could, of course, for example, test whether this coefficient is greater than 4 or maybe greater than 5. Then in that case, the test available already in the summary output won't be directly useful. All right, was there another question? Oh, right. So was it Ramraji that checked the critical value table? So over there, in addition to the degree of freedom, we also need to make sure we refer to the correct, probability part.
Oh, sorry, right. So it should be 95 as the probability, right? I don't know.
Yeah, the 0.95.
95, yeah.
critical,
0.95, right.
All right, how about the last part? How did you address it? Anyone?
It's just your beta plus or minus 0.005, which is your alpha, times your t value, which is 2.16.
Okay. Oh, right. It seems you build yourself.
Oh,
So-
were we supposed to use something different?
You could.
Oh, whoops.
Because it's did other students have alternative approaches for Parsi? Oh, okay. Anyone had ideas regarding Parsi?
I could just, I don't know, but I just looked at the values of the lower confidence limit and the upper confidence limit.
Mhm.
And I looked at the coefficient, I don't know, and the coefficient is between those two values. So I thought that I just used the coefficient, but because it's between those two values.
Mhm.
That's what I
Okay.
looked at. And
see. So in part C, we need to find the confidence interval for the change in sales given 1,000 increase in the amount of money spent on advertising, right? So notice that here, this given 1,000 increase in amount of money spent on advertising is directly about this coefficient. We do not need to time it, right? So here, this coefficient directly tells us for 1,000 increase in advertising spending, how much is the change in the sales, right? So, and conveniently, the output table gets us the upper and the lower confidence limits, so we can directly take advantage of it. However, if you would like to build yourself as Richie did, a confidence interval, we must take advantage of the standard error for this coefficient, then times it by the critical value of t value with this degree of freedom, and also 0.95 as the critical, the significance level for the critical value. Then we can build the margin of error by standard error times the critical value. Then that's how we can derive the confidence interval.
I have not understood a single thing of what you've said, Jerry. Could you repeat that, please?
Oh, I was describing how we can address part C to build the confidence interval. We need to, if we calculate by hand, we need to use the standard error of the coefficient times the critical value of the t. So in a critical value, we need to use the degree of freedom as 13, just as what we did in part B, and also use the level of significance of 5% or the confidence level 95% to build the margin of error. Then using the margin of error, of course, we can get the confidence interval. All right. I hope it helps you to understand how we can do the confidence interval for a coefficient. It's no different than from what we did last week to build confidence interval for a, other statistics like a mean or well, we only build mean proportion, right? So it's similar idea. We find the standard error, then the critical value, so we get the margin of error. Then it gets us the confidence interval. Okay. I hope you have a wonderful week.
Yes.
Thank you.
And thank you for spending the time with me. And yeah, we should have the last one next week, right?
I think Thomas is taking over your time next week.
Oh, really? Okay.
Yeah. Thank you so much for all the help you've given us. We appreciate it.
Thank you, Jerry.
Glad to have you here.
Thanks, Jerry.
Appreciate you, Jerry. Thanks. Bye.
Thank you.
Pleasure. Bye.